welcome all of you. Today we have to see op-amp parameters. So before we start the lecture, do like, share and subscribe the channel for more and more fresh content. So op-amp parameters are important because we can use them to compare the performance of various op-amp ICs and select the best suitable from them for required application. So the different parameters are: first is input offset voltage. So ideally for zero input voltage, the output of op-amp should be zero, but practically it is not so. Therefore, a small amount of voltage is applied at any one of the input terminals to make output voltage 0, which is called as input offset voltage. So it is expressed as VIOS, that is input offset voltage. So this is VIOS, that is input offset voltage. The value of input offset voltage is temperature dependent. It is temperature dependent. Then next one is input bias current. It is represented as IB. So the input bias current is the average of the currents flowing into the two input terminals of the op-amp. Suppose this is op-amp. So this is inverting terminal and this is non-inverting terminal. Therefore, the currents flowing into the two terminals. Suppose this is IB1 and this is IB2. Therefore, the average of these two currents is called as input bias current. So formula is here: IB is equals to IB1 plus IB2 divided by 2, that is average. Then next is, see here, the input bias current. Ideally the currents IB1 and IB2 must be 0, but for practical op-amp they do exist due to finite value of input impedance, that is Ri. Due to slight difference in the characteristics of transistors used in the input stage of an op-amp, the two currents IB1 and IB2 are not equal. The maximum value of this input bias current is 50 nanoampere for IC 741. The value of input bias current is also temperature dependent. It is also temperature dependent. Then next one is input offset current. It is the algebraic difference between the currents flowing into the inverting and non-inverting terminals of op-amp, called as input offset current. Mathematically, it is expressed as follows: IIOS, that is input offset current, is equals to mod of IB1 minus IB2, that is algebraic difference. Then next is CMRR, that is common mode rejection ratio. So practically it is very high, but ideally it is infinite. Not infinite practically, it is ideally infinite, and practically it is very high. So however, it is very high for the IC741. The CMRR is 90 dB for the op-amp. Such high CMRR helps to reject common mode signals such as noise. Then next is power supply rejection ratio, that is PSRR. It is the change in an op-amp input offset voltage caused by variation in the supply voltage is called as power supply rejection ratio. So see, it is changing, therefore write it as delta VIOS, that is change in input offset voltage to the change in supply voltage. So this is power supply rejection ratio. It is expressed either in microvolts. It is expressed either in microvolts per volt or in decibels. Ideally, it is not equal to 0. For IC741, PSRR is 150 microvolt per volt. It is also called as supply voltage rejection ratio, SVRR. Then next is slew rate, SR. So slew rate is defined as the maximum rate of change of output voltage. This is maximum rate of change of output voltage per unit time. So it is expressed in volt per second. It is expressed in volt per microsecond. So the slew rate decides the capability of op-amp to change its output rapidly. It changes with voltage gain. Ideally, it should be infinite and practically as high as possible. For IC741, slew rate is 0.5 volt per microsecond. Then open loop gain for the differential mode gain. Gain of op-amp without feedback is called as open loop gain, as we seen in the last lecture. Therefore, it is expressed as AV, that is open loop gain, is equals to V out upon V in, that is output voltage to the input voltage. That's simply gain. For ideal op-amp, it is infinite. For IC741, open loop gain is this much. Then next is closed loop gain. It is the voltage gain of op-amp with external feedback. It uses negative feedback. Due to negative feedback, gain is reduced but stabilized and there is decrease in distortion. So it is expressed as AVF, that is closed loop gain, is equals to AV, that is open loop gain, upon 1 plus beta AV. So this is the formula for closed loop gain, and beta is feedback fraction, and beta AV is loop gain. For IC 741, closed loop gain is 1000. So these are the parameters of op-amp. Thank you.